Okay, hey everyone, good morning. Welcome back. Hope everyone's doing good. Had a nice weekend. It's Monday, April 12th, and we have about 3 minutes till we start. So, hope everyone's doing great, and I'll be right with you guys. Morning, Kylie. Good to see you. Couple minutes to go. Hey there, Sydney. Welcome back. Sebastian, nice. Good to see you. Hello, how's it going?
Hi.
What's up?
Good. I was just looking. I haven't been in the classroom in so long.
I know. Is it Dennis?
Yes. Wow.
Yes.
Nice to meet you.
Yeah.
Finally, nice to meet you.
Yeah, for sure. Good to see you here. Hi there, Claire.
Oh my God, you're like so active on the chat. I was like, I think it was you and Chloe, I think, or the other person.
Angel,
You made the
welcome.
last one. Sorry, that's what I was trying to say.
Thank you.
I'm
What a
Dennis.
compliment.
Nice to meet you.
Cool. Okay, just another few moments and we'll get today's meeting underway.
Is it usually just you?
It's been a couple others.
Yeah, there's been a couple others. I think I'm the most consistent.
Yeah, for sure so far.
I would have come earlier, but I wasn't in the States. So.
Oh yeah, no worries about it. Hey there, welcome back. Hey there. Okay. Cool, so thanks everybody for being here. I'm just gonna get the meeting underway. We're pretty much at 10 a.m. So as usual, appreciate your guys' attendance and all your preparation and focus on the class. Today we have another clear lesson plan. We're definitely on track with the schedule and the calendar of dates. So what we are talking about today is Ted Sider's article called Time. I started to open up the discussion of it a little bit at the end of last meeting, but we have more to cover today to finish it up. So let's just try and get into it. First of all, and hey there, Lane, welcome back. We got 4 people in the house today. This is the most we've seen. I think 3 is the previous record. So yeah, let me just try and talk you guys through some of the review of the last lecture, and then we'll pursue some additional notes from there. So we're now on the topic of time in this class, and we started it by looking at and reviewing the words and the writings of Albert Einstein and the theory of relativity. So I know we've covered that in sufficient depth already, but I'm just going to say briefly that in his example, he says, suppose there were 2 lightning strikes that occur at separate points on a railway embankment. Question, what if they happen simultaneously? What would that mean? He says it's not so easy to define this as it seems at first, but he gives it a shot, and he says the right way to define it is basically as follows. Measure the distance between the 2 points A and B. Place a motionless observer standing at the midpoint M between the 2. And if this individual sees the 2 events happening in one field of vision at the same time, then relative to him, they would be simultaneous, as long as we assume one further stipulation, which is that the speed of light is always fixed and constant. Assuming that the speed of light moves from the same velocity from A to M as from B to M, and that they reach point M at the same time, then given their same velocity and the equal distances that they've traveled, they must have departed from A and B at the same moment. Therefore, they would be simultaneous relative to the motionless observer. But if we take a second observer who's passing through the train situation with velocity v, and they traverse midpoint m prime, just as the other individual is doing their own observation from the motionless position of m, then the second observer will see b happening before a, given the fact that they are closing the gap between themselves and b and opening up a wider gap between themselves and a. Hence, the equivalent speeds that the two light rays are traveling cannot possibly reach him at the same time since they're moving asymmetrical distances to get to his eye. So in his experience, A and B are not simultaneous, but it is B happening and then later afterwards A, just a moment later. And so the puzzling result there is that the same two events cannot be given any objective ordering in the time sequence. On one account, they're simultaneous. On another, one happens prior to the other. And from a third possible condition of observation and a different state of motion, we could see it happen in the reverse order. After this, we talked about some additional implications of Einstein's work, like, for example, the twins paradox and the concept of time dilation. Time dilation I explained via the example of a light clock, a system which would record measurement of time by the consistency of light that goes up and down between two reflective plates. Well, if one light clock remains at rest and the other one is accelerated very fast, then the fast-moving light clock is going to record fewer seconds than the one that remains at rest relative to a motionless observer. So then time passes at different rates depending on the object's velocity relative to other objects in space and time. And that's very strange. Obviously, that means that if we had a pair of identical twins, we could have one of them accelerated very close to the speed of light, return to a state of rest with their counterpart, and they would have aged much less slowly than their counterpart would have, depending on how fast their speed was and how long they were traveling at that rate. So very puzzling and weird things. You would have thought time passes at a consistent rate for everybody, and I guess happily for us, because we're bound on the surface of the Earth and we can't achieve greatly divergent speeds, we don't observe these phenomena. But they're real, they're measurable, they've been tested, and so that's a very weird and trippy implication of the Einstein's material. Now, after that, we started to dive into the work of Ted Sider, and that's the main point of today's meeting, to finish his essay. So let me just add some notes to the board. Yes?
So for like the oh yeah, I remember. So I was trying to explain this to like my friends,
Yes.
but I like wasn't doing a good job. So
Mhm.
I was really confused.
Yes.
But so the twins still age at the same rate. It's not like the age that they're.
They age at different rates. No, that's not true. They age at different rates. The one that's going fast is aging slower, and the one that's staying still is aging faster. Simple.
Okay. So it's not like
You must force your brain to abandon the assumption that there's some illusion about this and that time is still passing the same way for both. It's just that it appears that one, like, well, maybe this is what you mean. Relative to themselves, they don't experience like accelerated time. It's not like they're looking at their clock and they're seeing like, it's just that they're moving at a different rate. So their own clock is moving with them. The one that stays on their wrist is going to show time in the same way as it would have, except when they get out of that state of motion and they compare it to another observer's watch who's moving at a different rate, they will no longer be in synchronicity.
I think I was just getting confused between like the rate of aging and the rate of time passing, but they're the same.
Well, yeah, they're the same, but the experience of the individual is still going to be like feeling time pass at the same rate.
Yeah.
But it's in the comparison and the contrast between two different
Okay, yeah.
frames of reference that you would see the discrepancy.
Okay.
It's not like the discrepancy is observed and experienced by the first person if they never encountered anyone else. So if you're just an interstellar traveler on a spaceship, you're just going through your life like each decade. But it's only when you would return to Earth and see the people who'd not been traveling at that fast rate that they are significantly older than you relative to the amount of time that you spent. So 5 years for you in the shuttle is like whatever, 20 years for people back home.
Okay.
Cool. Okay, yeah, it's just some questions from the class, so I wanted to deal with those. The question was about like how to conceptualize the idea that time's moving at different rates. Like, do the two individuals feel like the time is moving at different rates? No, not from the first personal perspective, but in any kind of actual comparison between elapsed time on their like time measurement devices and in their own, stage of development as a human being, it would show differences from others that were not moving at the same rate.
Is that time that's what Einstein's doing?
Yes, that's according to the theory of space-time from Einstein. Okay, so now what we're doing is we're going to try and expand on this guy's material. Theodore Sider, aka Ted Sider, and American philosopher, still living, and he was born in 1967. and the article from 2005 that he wrote, which is called just Time in our textbook. Okay. So anyway then, Ted Sider, Theodore Sider, Time, 2005. He wants to explore some of the big puzzles and paradoxes that emerge when we start to investigate the concept of time, in depth. And he says that, time is something that we all just take for granted. We live according to the clock. We arrange our schedules in time. We're intimately aware of the passage of time, but we don't usually ask deeper questions like, what is it? How to analyze it? We just live with it, but we don't usually do this analytical thing that philosophers and scientists do. But he says that we should do that because as soon as we start to investigate it in any depth, we notice that our ordinary ideas about it break down a little bit and stop making sense. So the first thing that he says is puzzling about time is the way that people say that time moves. So I'll put the point here and continue to describe it. He says time is puzzling because, well, among other things, because people say that time moves. Moves. Time is puzzling because people say that time moves, and he directs us towards, oh, thanks, Cordy, appreciate your comment. He says that the idea that time moves calls to mind certain phrases and common sayings that are well known and popular, like time flies, time is passing, time marches on, time is flowing, time is running. So people, when they use these statements, they are expressing metaphors of motion: to run, to march, to fly, to pass, to flow. These are things that objects do when they're actually moving through space. So if we think of time at all, what these cliche phrases and sayings tell us is that we think of it as something that's a moving system, and we're somehow caught up in the flow and the movement of time. But again, it's puzzling and it's hard to explain because ask yourself, what is the standard according to which time moves? This seems to be a puzzle because to define motion itself, we have to make reference to time. So additional claim below. The movement of time is puzzling because to define motion, we need to refer to time. Let me put it this way, explaining how time moves. Is puzzling because to define motion itself, like even spatial motion, one needs to refer to time. So motion is defined with reference to time. And let me just show you a quick example of this. I think I tried to demonstrate something like this at the tail end of the last meeting, but once again, say that this marker that's in my hand right here, or even just me, here, I'll make a better example of my own body. So right now I'm standing over here at this side of the panel of this whiteboard, and I'm just going to move over there to the other side of it. So let me demonstrate. Here you go. So it happened, I moved. I went from point A, let's call that point A, to over here, point B. And how did I move? I mean, by being in different places at different times. So what is it for something to move? The definition of motion is for an object to be at different places at different times. So like, at the beginning of me moving, I was standing over here. And then if you looked at the clock, a couple seconds passed, and at different time points, I was in different positions. If I had stayed in the one position for all time, then I wouldn't be moving, right? So if I stay in this chair that I'm in for the rest of time, then I'm never moving again. So to move, you have to be in different places, but at different times. Therefore, time is referenced in the definition of motion. And so if we plug time itself into this definition of movement, then it would seem to be that this is the analysis. Time moves by being in different places at different times. But now we have given a circular definition. We've referred to time in an attempt to define its own motion. And that's going to lead us into the direction of an infinite regress, which won't explain anything. To make the point even more vivid and clear, here, I'll show you a graph that the author puts in the book, which explains his thinking on this. So I'm going to erase this part of the board, and then we're going to add the graph to the board and to the notes. This graph you would find in the book also on page 458, figure 1. But anyway, here we go. So what the graph is going to basically display is a diagram that shows the motion of a train from its origin out of Boston to its final destination in Washington, D.C. So here we go. The graph consists of 4 horizontal lines like this. And then in the graph, to the left, we're going to just put 4 time indications. So lowercase letter t with a subscript 1. And so it's going to be t subscript 1 through 4. Time 1, time 2, time 3, and time 4. Now below, in each of the 4 horizontal lines, we're going to designate 4 place names that the train passes through on its route from Boston to Washington. So starting in Boston, BOS for Boston, moving on to New York, then Philadelphia, before finally arriving at Washington, D.C. And we're going to replicate that below each of the 4 lines. So just get those little indications in the graph. Okay, so now think about this. Suppose that we say this train moves from its origin out of Boston and moves all the way through to its final destination, Washington. To say that it moves is just to say that it's at these different places at different times. So now we add the train itself to the graph. It starts in Boston at the first time, initial time. So this time 1 means that it's before the subsequent number. These numbers order the linear time sequence. So this is earlier, later, later, and then still later. So at the first moment, the train is departing from Boston. Later on, after time 1, sometime later in the day, it's in New York. Then at a third and even subsequent time from there, it's in Philadelphia. And finally arriving to its destination later on after the third, it's in Washington, D.C. So looking at the graph, what you see here is this. The train is moved. But how has it achieved motion? By being in different places at these different times. Now, if I had altered this graph, guys, and I made it so that the train was Boston, 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 Boston at all 4 times, then in that case, would the graph show the train moving? No, that would show a graph of a train that just stayed put in Boston and never departed the station. So understand, therefore, this graph is hopefully making it very clear that when things do not move, they stay in the same place all the time. The time keeps changing, but they're not going anywhere. They're staying in the same place. When things move, they're in different places at the different times that exist. So now, to say that time moves leads us into this circle. Because if we try to model it on the understanding given here of the train moving through space, we would say that, well, time is moving because it's in different places at different times. But then we would be invoking the concept of time in its own definition. And then the definition would no longer be non-circular, so it would not be explanatory. It'd be like saying a dog is, one of those dogs. This is a definition of a kind, but it doesn't say in other words what the thing is. And so say time moves because it's moving with time is again circular and not helpful. So he says there's maybe another attempt to try and, explain this basic concept that we all seem to have, that time moves. So let's try again. Maybe when we say that time moves, we're saying that it moves because the present moment is moving. I don't want to move on too fast. Last thing, okay? Just to repeat. This graph is messed up because it's showing that an object moves with respect to time. So if time moves with respect to time, then we are using a second order definition of time to ground the movement of the first order type. And that would lead to an infinite regress. So what's another attempt to explain it? Maybe by saying that the present moment is moving. And that's what we mean when we say time moves. So let me try to explain this. What time is the present? Well, it's right now. Right now is the present moment. So if you look at your watch, at least while we're watching this live, some people are going to be watching this on video later. It'll be confusing to them. But if you're watching it live right now, the present moment is like 10:16 a.m., April 12th, 2021. So that's what time it is right now. But to say that time moves, maybe what we mean is that that present moment just doesn't stay put. And that's the idea. So, yesterday, this time we're in was the future. Remember yesterday when it was Sunday and you're like, oh, tomorrow I got to go back to class. but that wasn't the present moment yet. Now it is. And now yesterday, which was the present moment for you then, is in the past. And what we're all experiencing right now, this present moment, it's going to be the past. In fact, it already is, the time that I just mentioned, so it's already gone. So you could say that the present moment keeps sliding around, like at this point, it's 10:17, but in an hour, this will be the past, and 11:17 will be the present moment. And then later on in the day, 3 p.m., 6 p.m., 9 p.m., those will be the present moment. So maybe time moves by the present moment moving. Does this work better? At least initially, it seems promising, but as philosophers are often, he says, I'm sorry, but it actually still doesn't quite explain the thing, and it's still a puzzle. So let's try and draw a new graph, though, to at least show the attempt. So I'm going to erase this one, and we're going to draw a similar graph, which is going to try to capture the idea that time moves because the present moment is moving. So here we again have 4 horizontal lines. And in this case, instead of 4 place names underneath the bottom, we're going to designate 4 different times on the clock. So starting with noon, 12 noon, right around lunchtime, 3 p.m., afternoon, 6 p.m., early evening, 9 p.m., getting to the later evening. And we're going to show the same sequence under each one. So basically 12, 3, 6, 9. But I'm writing noon so that you know it's not like 12 midnight. Okay, now over here to the left, we have the time coordinates organizing the graph. And now instead of showing a train moving from place to place, we're going to write the word present, and that's going to try to show that the present moment doesn't stay in the same place. So like, for example, at an initial time, let's say 12 noon is present. So you're eating lunch, and you're like, this is happening right now. Nice. Later on, though, lunch is all digested, and now you're on to whatever your 3 p.m. activities are, looking back at lunch, but now it's 3 p.m. that's present. So this is the now, at that second subsequent time. And at a third, even later time, it's 6 p.m. That's the present moment. And finally, I don't know, as you're studying, doing homework, getting ready for bed, watching stuff on TV, Netflix, or anything else, YouTube, it's 9 p.m. That's the present moment. So does this graph help to explain what the author is trying to get at, which is how to say that time moves? We seem to be caught in a puzzle because one way of looking at it is that saying time moves refers to motion, which refers to time, so the definition becomes circular. Does this help us more because it says it's the present moment moving? Well, I guess it looks nice at first, but here's what he says. Ultimately, no, this doesn't explain anything because there's one issue with the graph. I don't know if it's going to pop out at you immediately. If it doesn't, I'll help you. But can you see something on this graph that's like undefined? Well, that's an issue, yes, but it's not so much that. There's a specific item on the graph, if you look at it, which we're using to define time moving. We're using it to define the present moment moving, but it itself is undefined. What could that be? Anyone? Shown on the graph, an undefined term, or terms, little hint. These things are supposed to be showing us how the present moment is moving. Well, it's not the noon 369, although I see why you would say that. It's these 4 things to the left, the time coordinates, T1 through 4. Ask yourself, what are those? It looks like they're 4 what? Times. Yeah, they're 4 times, but we're trying to define time's motion with respect to these things. But these things are undefined. So ask yourself, well, what are T1 through 4? Well, it seems like a linear time sequence. But how can they possibly be placed in that ordering unless they themselves are graphed in an even larger graph with respect to which they fall within an even broader time sequence? And that would lead to the branching out into yet a further graph. So the first order time is defined with reference to second order time, which is defined with reference to third order, with fourth order to infinity. And therefore, we're not getting a non-circular analysis. It keeps looping back to a time reference in order to try and define the concept. So he says it looks hopeless, really. I mean, trying to say that time moves is tying us up in knots because it requires us to define the concept of motion, which once again uses time itself. And therefore, he says we're hopelessly lost trying to explain how it is that time moves. Even though it's such an obvious idea that we all carry with us and just take it as a given, he says it does not make sense. So, you ready for this? He says there's a better way to get out of the problem. And his solution is this. Let us simply just completely abandon altogether the idea that time moves and instead embrace the Einstein space-time theory. Because if we do that, we no longer have anything to explain. If time doesn't move, then nice. You don't have to explain how it moves because it just doesn't. On the space-time theory, time doesn't move. It collects and contains all the moments of time and space as one big uniform system. So nothing starts happening, stops happening. All the moments, including past, present, and future, are equally real and all coexist. And according to this view, which is an implication of Einstein's space-time theory, because if simultaneity is relative, then it's also relative what's happening now. And therefore, all the events, given some possible condition of an observer, can be claimed as real and factually exist. So that's nice because it gets us out of the one puzzle, having to explain how time moves, but we still have some other difficulties, which is, how then are we supposed to understand the nature of objects and even ourselves according to this space-time concept of the universe instead of the traditional idea that time moves? Well, he says, I'll help you with that. So if we want to have a detailed understanding of objects and events according to the space-time theory of Einstein, then we have to showcase and point towards what are called space-time diagrams. And one of these you'll see on page 460 of the book. I'm going to try and represent one here on the board as well. Okay, so just a reminder of the state of play. Ted Sider says, time is weird, it's hard to explain, people usually don't think about it, but when you do, you start to realize that the ordinary idea of it's hard to comprehend because we say time moves, but saying time moves is very difficult to analyze since any analysis of time moving points us back towards the notion of time itself since motion depends on the concept of time. So what's better than trying to explain it? Giving up and saying time doesn't move at all, going with Einstein's view, which as weird as it is, eliminates the need to explain the movement of time because it's claimed that it doesn't. But now we're asking this, how do we reconceive of objects and events if in fact there's no such thing as time moving? What is the space-time theory as it pertains to objects and events like us? Okay, so here's a space-time diagram. The first thing that we're going to show is that it has these two spatial axes. Making sure I have the best marker. Okay, so this is our y-axis, it's the horizontal axis. This is the x-axis, the familiar vertical axis. And then shot through it, intersecting, there's this horizontal axis, which we're going to label t for time. Now, in a true space-time diagram, there'd be four dimensions. You have your three spatial dimensions and the one temporal dimension. So time is the fourth dimension, and the three spatial dimensions are like height, length, and depth. But height, width, and depth. In this case, since it's a two-dimensional board surface, I can't display the three spatial dimensions. So you have to pretend that this is our typical horizontal spatial axis, this is the vertical one, and then the depth one is just obscured. And this runs through the intersection of the two of them, the time dimension.
What's the title for this?
It's a space-time diagram, and it's shown on page 460. It's figure 4. Okay, so anyway, on this diagram, the space-time diagram, we can depict the existence of objects and events, including things like ourselves. So here I'll put one of these. So say that on the time dimension, we draw a hash bar here, which stands for the year 2003. I'm dating it at 2003 because I know that in this class there's probably certain freshmen, and some of you may be born around that year, if not, I don't know, 2002 or something. But anyway, let's suppose a person's born at that time and they have a nice full life. Like I'm wishing for you guys to be like, I don't know, almost 100 years old. Now, to fill in the rest of the diagram to showcase the existence of this person across time, it goes as follows. Okay, now I've drawn a series of stick figure type inscriptions here on the graph, tracing from the beginning point of 2003 all the way through till the end point of 2100. Now, why is it that the graph discontinues at that point? Because it's the end of the human being's life. So that's like the end of their timeline on living. And it originates from 03 because we're supposing that that's like the birth year and date of the individual human being on the graph. Now, on this graph, what we're showing is the object's extension both throughout space and throughout time. So let me ask a couple of, I hope, not too tough questions about things shown on the graph. Question. Who thinks they know this? Why is it that I've shown the human stick figure shape to be smaller along the x-axis here at the beginning of the diagram where it appears at 03? Why do you think, simply, that it's smaller at this point in the graph, the human stick figure, than like, say, here in the midpoint of the duration? Getting older, but not just older, actually, because sometimes things get older and they don't change size. You ever seen people with like certain birth defects and they stay small forever? So it's close, but try again. Why do you think the size vertically along x is taller here than here?
Because you start as like a kid, bigger.
Bigger physical size, because like you said older, but older doesn't always imply growing in size, right? So I'm just trying to say it's getting bigger. That makes sense?
Mentally, or your brain changes, or physically, both.
Physically only. I'm just talking about size, because like this is a human being that's bigger than it was at the beginning. Like simply stated, you were a baby when you were born and you were mass like 10 pounds or something. Now you're much bigger, full-grown adult, so whatever, you're like 150 pounds or something. So you're bigger physically. So that's shown in the graph by the literal size of the stick figure changing across this timeline, you know? Because you're not bigger at the beginning, you're smaller at the beginning, and then you get bigger. Okay, hopefully that makes sense to the guys here in the chat. Good, Cordy. It reflects aging and growing, but let's distinguish the two things. This is something that Dennis and also Cordy, you guys have both kind of conflated. Growing and aging, we're showing two different concepts. I'm just talking about the physical growth. But now I have a second question, so you can get to that. Why is it that the object that is the human shape stretches throughout this sequence along the horizontal axis from 03 to 2100? So how come we have horizontal extension? I asked you about the vertical extension, which is smaller at the beginning of the graph and bigger in the middle. That's to show that you're growing vertically in height. What is this horizontal extension supposed to represent? Now we can say that. Time. That shows the endurance of the object throughout time, so that it existed for longer than just a split second. In this case, we have a human being that's lived for like 97 years, so it occupies more extension along the temporal axis, which designates how much time it spent as an object that existed. So if there was an object that was, let's say, like a particle of antimatter that got like annihilated almost instantly after it emerged into the universe, then it would only have a single slice, like a single little blip on this, and it wouldn't have that horizontal extension. But for objects that endure for longer, that's shown on the graph by having more of that extension along the t-axis. Now, some objects in the universe, of course, exist much longer than us. The simple example I'm using is a human life, with, in this case, a span of 97 years. But, you know, there are mountains, planets, stars that last millions, even billions of years. And any of those could be graphed along the same lines in such a diagram. Okay, so on this diagram, the object stretches horizontally because of the time that it occupies. And it stretches along the other axes because of the spatial extension that it occupies. On this four-dimensional view of objects, objects have both got spatial and what are called temporal parts. Okay, so important key term to now add to this discussion. Temporal parts. What is a temporal part? Okay, so a temporal part is simply an object at a single moment of time. Okay, so temporal part is just an object at one individual moment of time. And on this space-time theory, objects like us have got both spatial and temporal parts. So spatial parts are just like the physical parts of the object that make it up. Like in this tables example that this computer is sitting on, the spatial parts would be like the legs, the tabletop surface, etc. In your case or my case, the spatial parts would be like your arms, legs, torso, head, you know, hands and toes, whatever, like the body parts that actually have mass that is sitting in your chair right now. But a temporal part of you is the whole person at a single moment of time. So these are like time parts instead of space parts. Spatial parts, space parts in space, temporal parts, parts in time. And on the space-time theory, your temporal parts, all of them, are equally real and they all exist. So I know your everyday thinking is when you look at a picture of yourself as like a little baby or a child, you're like, man, that was an interesting memory, but it's gone now and it's all over with. On the space-time theory, no, it's still there. It's in space-time, that temporal part of you from childhood, and the future temporal parts of you that in your experience you haven't seen yet. You being older, getting married, having kids, becoming a senior citizen, retiring, starting a business, graduating. Whatever those points in space-time are, if they are part of your timeline, they're already in it because all moments of space-time exist. You have to kind of get this in your mind. According to this theory, it's not just this present moment that's real. The past and the future are just as real as the present is. It's just that we only experience moments one at a time within our psychology, but they're all objectively real according to the theory. So let me ask you a question to see if you're tracking this discussion of the temporal parts. Suppose there's a photo taken of you, and you guys, everyone's taking pictures, right? So you know what's up with photos and pics. If someone takes a picture of you, or if you have a picture of yourself, how many temporal parts of you are displayed in that photo? A still photo. How many temporal parts of you are shown in the photo?
One.
Go ahead and type it out. Yes. Why do you say so?
Because that picture it captures one single moment. You can move a millisecond later, but the photo.
Good. Yes. A still photo just shows one individual moment in the person's existence. Like the light captured from the scene is recorded by the device, and then you can view it later, but it shows one moment in time. So it's simply one temporal part. And let me ask another question. Suppose a video is taken of you, like a short video, a little TikTok video or something, and it's like 30 seconds or less. How many temporal parts of you would be shown in this short video? Now, this is a kind of a trick question because I know a number will be impossible to give. But what kind of answer do you think you'd give for that question? How many temporal parts are shown of you in a short clip? Several. Well, yes. Let's kind of think of it in terms of an equation or formula. There would be just as many of them as there are what in that clip?
Frames.
You say frames, and Zoe, Cordy, I see you guys saying here. But let's think a little more deeply because frames have to do with technological limitations of the device. You have some devices that can capture 30 frames per second, some 60. And there are very advanced, like for scientific purposes, like million frame rate type of super cameras. So you got to think of like God's camera, like not just technologically limited, but the amount of moments that exist within the interval of time shown in the video. So it would be orders of magnitude huge. But Zoe, you suggest in the chat infinity. I would only push back on the suggestion of infinity for a few reasons. If there were literally an infinity of moments in even a short duration video, then it would seem like we could never exhaust any of these moments to have them finite and completed. Because if there's an infinity of them, even if each moment was very short, it'd be inexhaustible. So even like a short video, you could never finish watching. But of course, we do finish watching them. So it's just a huge number, and it would be equal to the number of individual moments or instants that occur within the captured duration of the video.
But how do you define a moment?
Well, okay. In physics, there's a minimum physical length called the Planck length. Max Planck was a physicist. And what he discovered is that space and matter is not infinitely divisible, at least not in physics. So when you get to the Planck length, things can't be subdivided farther. And since Einstein's theory of space-time says space and time are unified into one common structure, we should assume that there should be physically a corollary to the Planck length in terms of time. So some infinitesimally short interval beyond which it cannot be further divided. If you resist the idea to think, well, there's always a further subdivision of time, then you'd get to the thought that there's infinity. But I think that we'd have something along the Planck length to guide our thinking about what the minimum unit would be. So anyway then, guys, still frame picture, one temporal part. Video clip, multiple temporal parts. But they're all just as real as your physical body parts. So when you're looking right now, like at your left hand, I know it exists. You don't have any doubt that it exists because it's right there. And what you're being told by these theories and Einstein and Ted Sider is that the temporal parts of you are just as real, and you should have just as much confidence that they are real as the body parts that you're looking at right now. So if you think, oh, me tomorrow, that's something that doesn't exist yet. We'll see what happens, but it's not real. No, that future temporal part of you, if it exists, hopefully it does, is just as real as the left hand that you're looking at right now as you sit and watch this video. So continuing to go into this and explain it more. Another question. Are you, according to the space-time theory, let's see if you can think of this one. According to this theory that you're hearing, are you fully present as you watch this video right now? Are you, the person that you are, 100% present watching this? Consider your answer. According to this theory, anyway, would you say that the space-time theory implies that you're fully present right now or not? Are you present watching this video? You're saying yes. Too fast. Think deeper. Why do you think the answer is no, you're not fully present as you watch this?
Because the present.
No, because okay. What are you? The full thing that you are. Well, let me get in some comments from chat. Kylie, you say yes? No. No. The answer is no. So why is it that you're not fully present as you're watching this? What is present? Cordy, let's see your answer. No. The future me that won't be watching it exists just as much. Correct. So what is actually watching this lecture? Some of your temporal parts, like just a couple of them, a little span along your timeline, the span that exists from 9 a.m. on April 12th, 2021. Sorry, 10 a.m., thank you, April 12th, till 10:50 a.m. That little interval of your temporal parts sits down and watches this lecture right now. But what about the temporal parts of you that I never got to experience? All the things that happened to you between 0 and 18 before you even got to Chapman. And what about all the temporal parts of you after this, like after you graduate and when you're done with college completely and you're on to your, career or whatever? Those temporal parts are not watching this lecture, right? So you need to understand that on this theory, you're not even fully present right now. Just some little subpart, some subsection of you, a subset of your total aggregate of temporal parts is watching this. So what is the whole thing that you are on space-time theory? It's not just a few temporal parts. It is the sum total aggregation of all of them combined into this one space-time worm that stretches throughout this diagram. So you're never fully present at any single moment of time. Transtemporally, collecting all the moments as one into one big space-time worm, as they sometimes say, that's the whole thing that you are, but you never experience it psychologically at an individual moment because you psychologically experience one moment at a time, although all of them are real according to the theory. How weird is that?
What if you, I was just thinking, I remember one Christmas, I spent 2 Christmases because I was traveling because my home's in Korea. And so I spent Korea there, and coming back here, you lose it back a day. So there's another Christmas there. Or if you do the same things, like the exact same, you plan everything to the minute, to the second, and you come back here and you do the same thing, wouldn't that be more temporal parts of you? You did 2 things and you combined it more?
Well, I mean, I think
It's
you have
still
to.
the same time, right? Like you did it exactly the same. Is it technically the same date?
No, it's a different date because it's a different moment in time. I mean, like, so you do something there, then you do something here. These are 2 subsequent events. So they're running along a sequence, like something happened earlier and something happened later. But the repetition of 2 similar events is not like the same thing happening literally again. It's like a different instance of the same kind of thing. Like, so if you attend this class on Wednesday or next Monday, it'll be, I could even like say deliver an identical lecture, but it would not be the same moments in time, right? It's a whole different moment in time, and you're older at that point than you are here, or at least to speak precisely, the temporal part of you that would then attend that future lecture would be a subsequent temporal part in the organization of your stages. So like, let's say you, for example, celebrating Christmas in Korea or whatever, if it was before a later event, then in your graph, like let's say the date and time of the first event would be like marked off here. And then when you did it for a second like celebration after you go to the next location, it'd be like at a second point. But it's not like literally the same point in time because the graph will show the time's got all these different points. Does that make sense?
Yeah.
So you should not be thinking like, this is just kind of word games and stuff. When you do 2 things, that's what the authors are calling the same thing. No. It's metaphysical. So like literally, you exist at all these different time and space points. You exist in the future and you exist in the past. So you in the future graduating is real right now. Like it's not something that's gonna happen. It already exists in this universe. So the weird thing is, why is it that you only experience one moment at a time, given that all the events are objectively real, going back to your birth, all the way through to your death? Okay? And you had a comment over here or no?
Yeah, I think I got a little confused, but what you're trying to say is that although the time technically is the same, because with the plane, you travel back, whatever, the moments are not the same. Time does not equal moments, right?
Well, the time's not the same. Are you talking about like
It says that, let's say, it's time difference.
you're talking about like time zones and stuff? So it's like right now it's 3 hours later on the East Coast. Suppose I fly really quick over there and I get there within 3 hours. So now I'm like experiencing 1 p.m. twice. Is that kind of what you're talking about? No, they're totally irrelevant. Stop thinking that. That has nothing to do with this. Time zones and all that.
It's the same day,
Hmm?
exact day. Going to different countries, it's going to be the same day. You're going to be experiencing the same time.
But it's not at
It's
the.
not like a 3 hour difference. It's like the same December 25th.
Well,
9 a.m. That's what I'm saying. You do exactly the same thing at the millisecond. Like everything's exactly done the same way.
what are the two? So same implies two. So what are the two things that you're saying are the
Well,
same?
I'm just saying, say like I had an event planned, like the whole day was planned to the millisecond.
Yes.
Theoretically,
Mhm.
everything was done exactly the same. My movements, everything was done the same. Wouldn't that be more temporal apart? That was my question. It's the same day.
Same day, but you see, my only just
Sorry.
everyone here in the chat, I'm just trying to clarify one student question. It's okay. Well, you understand it. Someone has to let me understand it. So you're saying that if you have a day planned out to the T,
To like exactly.
to every single thing that you will
Yes.
do during the day, yes. And then what? Go ahead. No, I'm just
Exact-
asking.
So like you do everything exactly the same as I did in Korea, and I come back here to States and I do the exact because it's 25th again here.
Yes, yes.
I do exactly the same, my same routine, everything.
Same routine, yes. So like, let me try and understand you. Say that in 2020, you had a Christmas holiday in Korea. And then in 2021, this upcoming Christmas, you replicate it down to the last detail in America.
Correct.
That's what you're explaining or describing, right?
I mean, yes.
Okay, and so
Same year.
same year. Okay, so same year then. So like say December 24th, you do something here, and then you take a flight, and then you observe Christmas on a different date here,
25th, same day, same time. everything.
both in Korea.
December 25th in Korea,
Yes.
December 25th in the United States,
Uh-huh.
same exact time. Say we start at 9 a.m.
Uh-huh.
9 a.m. here too. We just
Oh, okay, so like through Zoom and stuff?
No, just in person. I'm just saying as a
You're
temporal.
saying because you fly back, and so it's because of the time zones.
The time zone thing again. Is that what we're still talking about? Time zones?
No,
Give
we're
him
not-
a marker.
So, well,
Say like when you travel really far and then you travel back, and it's like you're reliving the same day because
Yeah,
you went
that's what
to
I'm
a
saying.
different time
Does
zone.
that
It
mean
is a
you'll
time
get
zone
more?
thing.
it's a time zone thing.
Okay.
It's a time zone thing. This time zone stuff has nothing to do with it. The passage of time is not the same as.
Just because the date is defined as the same date.
No, it's not. It's a total misunderstanding. No, time zones have nothing to do with it. So you gotta, like what I was saying before, eliminate any discussion of time zones because it's not relevant to the theory of space-time. Time zones happen because we have to have clocks that are coordinated for the time of day that people experience. So on one surface of the Earth, which is bathed in sunlight, because we have a curved surface that rotates on its axis, we assign the times of the day as like daytime hours. And in parts of the world where there's no light, we assign to the clock nighttime hours. But it's not as though when you travel from one place to another and the time zone causes it to be the same time again, that this is somehow like the same temporal parts. No, it's subsequent temporal parts because as you know, you're getting older no matter whether you're looking at the clock and the clock, it's not like you could say, keep going back and forth and never age because you're tricking the clocks. That's not how it works. You're still aging because time is passing despite what the clock face is showing. Okay, but questions, okay? When you are looking at this space-time diagram, one thing that we said is that you have to understand that you're constituted both of spatial and temporal parts. A temporal part is an object at a moment of time. And the aggregation of all of your temporal parts extended throughout the past, present, and future, if we could somehow see them in this kind of worm-like structure, that entire stretched out diagram thing is the set of temporal parts that makes up what you are. So on this four-dimensional view of objects, we have spatial and temporal parts. Sometimes people call these temporal parts like a time slice, and that's because of like, if you were to say cut a cross section through it, if this was like a loaf of bread or a big deli loaf of meat, one thin slice through it would be like an individual temporal part in your existence. So like a freeze frame of your life captured at one moment of time, that would be one of the temporal parts. And you're the sum aggregation of all of them. So on this view of time, reality consists of a single unified space-time containing all of the past, present, and future. Let me read it in the book and you can see what it says. In contrast to the ordinary conception of moving or flowing time, the space-time theory says that reality consists of a single unified space-time which contains all of the past, present, and future. Time is just one of the dimensions of space-time, alongside the three spatial dimensions, just as it appears in the space-time diagrams. Time does not flow, it is like space. So it just sits there containing all the events of the universe, but it's not moving. Nothing's coming into being, nothing's passing out of being. So the moments, they just exist on this timeline and they're there forever, including the past and the future. In our ordinary lives, we think the present moment's all that's real. We think that just right now is real, and the future, what you're going to do tomorrow, there's no fact about it yet. It's totally indeterminate and undefined. But on the space-time theory, that's not true. All the events, whatever they were in the past and whatever they will be in the future, are already there. And so in a sense, that means that you're powerless to do otherwise than what you actually do, even though you have this kind of illusion of free will and freedom. Now, to get further into it, what are three similarities between space and time? According to the author Sider, for you to reconceive of time on this space-time picture, you have to see it, space and time, as having significant similarities, more so than we typically think. So the last thing that I'll have to say about this, and we'll continue with this, take just a few minutes at the beginning on Wednesday, are what are these three so-called similarities between space and time, according to the space-time theory? So three similarities between time and space. According to the space-time theory of Einstein. Okay, so we have these three big similarities, and this will be explained. The first one is what the author puts it in terms of reality. Two, in terms of parts. And three, in terms of the words here and now. Here and now. Okay, so one of the last things that I'll have to say about the article of Ted Sider is how to understand these three claimed similarities between space and time. Because yes, to fully understand this like changed picture of time and space that is offered by Einstein and Sider, we have to see how time and space have more in common than we normally think. But these three things will take just about 5 or 10 minutes to say at the beginning on Wednesday. On the topic of time, I saw this movie years back, Donnie Darko. It's pretty cool. It's a very art house kind of film. But they play with the concept of time and time travel and the metaphysics of space-time theory in the movie a little bit, even though it's certainly just for a novice audience, people that are not so versed in this stuff. But in a couple of scenes, you see this scene where, like, out of the chest or whatever from the solar plexus of Donnie Darko, you see like a projection of like a worm-like structure, which shows the direction of travel that he will have as he like gets up from where he's seated or standing and takes his next motion through space. According to the space-time theory, you and me and all objects in time and space have a world line that we trace. And so it would be like a trail that followed you to your current seated position, taking the steps that you took in life to get there. And it continues from your seated position off into space-time through the direction of travel that you'll take from here. And there is this one line which actually contains all of those moments, like in the space-time diagram that I showed before, which has like these different sections that you can cut cross sections through. So you experience like one frame of the space-time worm at a moment, but in like metaphysical reality, all of them are real, including the future stages that exist subsequent to this present moment. So just there's a lot of science fiction and film that's explored these heady concepts for the purposes of like entertainment, but also, you know, kind of philosophical reflection. So we'll talk a little bit more about Ted Sider's work on Wednesday. I really appreciate you guys being here today. I guess if the space-time theory is correct, then you're powerless to control whether or not you will be here on Wednesday. So I'm hoping that fate and destiny brings us back together like it already has for the first couple of meetings. So have a great one, guys. Let me know if everything's okay, and I'll close the live stream, and then we can see you guys in a few days, 48 hours. Everything cool? waiting for them to give me the okay. Perfect. Okay, thanks, Zoe, Claire, Cordy, and everybody else. Appreciate your guys' help and contributions. I'll be sending off the prompts for the next essay, but later in the week, so probably towards the weekend. Anyway, just keep your head up for that. All right, then. Have a good one, and I'll see you guys soon. Bye-bye. Yes.
Do we have another return